So you see that this is exactly same. It means that the implementation which we did is exactly same to the implementation that is given in the pycryptodome library. Today we will learn about the cipher feedback mode in the block ciphers. So let us say that we have three plaintext blocks: plaintext 1, plaintext 2 and plaintext 3. Now after this cipher feedback mode, let us suppose that the plaintext 1 is encrypted to ciphertext 1. Now, as the name suggests, cipher feedback mode, so the ciphertext 1 is going to be feedbacked in the block cipher. So, we will take this ciphertext 1 and encrypt it using our given block cipher, for example AES. So that block cipher will act and encrypt on this ciphertext 1 and form the intermediate 2. Then this intermediate value is going to be XOR'd with the plaintext 2, and the result of this XOR is known as the ciphertext 2. So it will form the ciphertext 2 of the plaintext 2 by the XOR of intermediate 2 and the plaintext 2. Now, the same process goes on, and the ciphertext 2 is encrypted using the block cipher and form intermediate 3. Then this intermediate 3 just XOR with the plaintext 3 and forms the ciphertext 3. Now the question arises, what about the plaintext 1? So for the plaintext 1, we employ an initialization vector which is publicly known to the sender and the receiver and also all of the attackers. So this IV is used to encrypt. This IV is encrypted using the block cipher and it forms the intermediate 1. Then this intermediate 1 is XOR'd with plaintext 1 to form the ciphertext 1. Earlier we implemented the CBC mode, and right now we will implement the CFB mode. So we will just take all the contents from our earlier file because most of the code is going to be similar, but we will delete the last code. Okay, so till here we have a function XOR bytes which is used to do the XOR of 2 bytes data type, and we have imported the useful libraries. Now we have generated the key, we have generated the IV, and we have initialized the cipher in the mode ECB. So this is to just use the basic mode of AES, and now we will implement it the ECB mode. So for it we need an IV which is generated in here, and we need some plain text blocks. So we do it like this: plain text is equals to square brackets. It means that it is an array. Now we create this array for I in range, let's say 10, and then we append it get random bytes and 16 bytes of data. So it will create an array of plain text that has 10 blocks with 16 bytes of data. Okay, now we need ciphertext, so we create a ciphertext array, and now we need to encrypt it. So first of all, we need encryption of an IV. So we use IV encrypt equal to cipher dot encrypt, and we encrypt the IV. Now we write the cipher text one command. So for that we just declare cipher text. Sorry, this command will not come here. So we use cipher text dot append, and now we will append the first encryption. So the first encryption is XOR bytes of plain text 0 and the IV encrypt. This is the first ciphertext. Now we add for all others. Ciphertext dot append, and we append it the XOR of, first of all, the plain text, and now we add the encryption. So cipher dot encrypt and cipher text I minus 1. This will give us the desired result. Now we run this program. Okay, we haven't printed anything, so we print ciphertext is print ciphertext, and now we run the program. So this is the ciphertext that we have got. In this way you implement the CFB mode. Now we do one more thing. We will use the CFB mode that is specified in the pycryptodome library. So we initialize the new cipher, cipher2 equal to AES dot new, and we initialize it with the key, and now we give it the mode AES dot mod, and we use the mode CFB. Now for this mode we need IV, so we will use the same IV, and we will then encrypt the data. But if you see, earlier our data was an array of bytes of each 16 bytes, but now we need the data in complete one element. So we just join all of the plain text. So plain text CFB equal to B dot join. This is to join all of the data, so we use plain text. Now plain text CFB will form the complete joined data. Now we encrypt it. So cipher text CFB equal to cipher2 dot encrypt, and we encrypt the plain text CFB. Now we print it. Print cipher text CFB. So this is the output. Now if you see, there are some discrepancies. This is 06 X8A 0679 B5. So it means they both are not coming same. So is it so that we have done some mistake? Let's find out. So first of all, let's convert the cipher text back into the one string. So we do cipher text equal to b dot join cipher text. So it will just print it as a one string. Now we will just separate it using one more print statement. Cipher text in CFB mode is okay. Now the problem that we encountered was due to the fact that in the CFB mode there is one more parameter, that is segment size. So segment size means that how much data needs to be XOR'd at one time. So actually the CFB mode works as a stream cipher, but we will look into this fact in detail in our later videos. For right now, we just take this segment size to 128, which is 16 bytes that we have just did at the above program. So we put here segment size equal to 128, and let us now look at the output. Now if you see, the output are exactly same. It is \n x80g, \n x80g, then xd8, xd8, xdf, xdby. So you see that this is exactly same. It means that the implementation which we did is exactly same to the implementation that is given in the pycryptodome library.